All right, moving into section 2.2, we are still going to be making graphs. But this time, these graphs are going to keep all of the original data. Where the graphs we made in section 1, it got lumped together. We lost our original data. Here, these graphs that keep the original data. So if you had thousands of data values that you're working with, you probably wouldn't choose any of these graphs. These are for smaller sets. But our first one we're going to cover today is the stem and leaf. Plot. You probably made some of these back in junior high. Here you take each data value and chunk it up into two pieces. The stem and the leaf part. A lot of your data values are going to share a stem, so we only write the stem once, and then the leaf is written for every single data point. So each stem is written once. So our first example is going to be to make a stem and leaf plot of those presidential ages at inauguration. So the U.S. president ages. Okay, so I have my calculator with them in order. And if you remember, our youngest president was 42, and our oldest was, or is, Donald Trump at 70 when he started. So you can see with a two-digit number, your 10th digit is going to be your stem, and your 1st digit is going to be your leaf. So we need stems of 4, 5, 6, and 7. So 4, 5, 6, and 7. So all of your 40s get in one row, 50s, 60s, 70s. Goes like this. And like I said, every single data value is included here. So what you should do when you have one of these is put your values in a list and get them in order, because the stem and the leaves have to be in order. So if you look, our youngest was 42, 43, 46, 46, 47, 47, 48. So I'm just going to start writing. The 1st digit gets written once. 3, 6, 6. So each of these numbers means 40. A 2-year-old, 43-year-old, 46-year-old, 46-year-old. 7, 7, 8, and you just keep going until you get to the 50s. And then we get 49, 49. Every data value is included. Now we jump back. We had a 50-year-old, and go in order. 1, 1, 1, 1, 1. Now 52, 2, 4, 4, 4. 4, 4, 5, 5, 5, 5, 6, 6. We're running out of room. 6, 7, 7, 7. Hopefully you were listening. 7, 8. Now 60. 61, 1, 1, 2, 4, 4, 5, 8, 9, and 70. And there they are. Then usually with a stem and leaf, you'll see a legend that will tell you what this represents. So they'll either take like the first number or the last number in it, but 4 bar 2 is equivalent to 40 years old, 42 years old. So that people know what that represents. So all 45 presidents are represented in our graph, if I counted that out right through there. Okay, see how there's so many 50s, they're all bunched up in there? When you've got it all lumped in that one, you can, if you want to see more separations, make what's called a double stem and leaf. So a double stem and leaf means you're going to write each stem twice instead of once. Times. So that means we're going to have 2 4s, 2 5s, 2 6s, and 2 7s. So we'll go ahead, we'll take these same data values. 4, 4, 5, 5, 6, 6, 7, 7. And now what you're going to do is anything on the lower part of the 40s gets written here, the upper 40s is here. So what's lower, what's upper, where's the break? Well, think about it. We've got the digits 0 through 9, so the 40, 41, 42, 43, 44-year-olds, 45, 46, 47, 48, and 49. So the 45 start here. So anything 40 to 44 is going to get written on the first one. And if you look, we've got them all right here. 42, 43, and then the 46, 6, 7, 7, 8, 9, 9 are all getting written there. So the 50s will get chunked up nice, everything through this last 54 on the first line. So 50, and then 1, 2, 3, 4, 5 of those. 2 52s, 1, 2, 3, 4, 5 4s. Now the 5. 7, 8. Now the 60s, everything through 4. And this 7 wouldn't need to be here because we don't have anybody in those upper 70s. And again, your legend should be there. P, whatever you want to call it. Okay, so there's a stem and leaf that keeps all of the data, and again, shows a nice picture. Turn it this way, it kind of looks like our frequency histogram, the bar graph. But yes, you can see where most of our presidents were at the time of inauguration. Okay, our next one is a dot plot. So graph number, technically third graph. I didn't number that. We'll call this one number 2. The double stem and leaf will be 2. Our third graph today is going to be a dot plot. And all this is it's a number line with a dot for each data value. So our example here, we'll take one out of the book to switch it up. We're going to go to number 21. Okay, so use a dot plot to display the data. The data represents the lifespan in days of 40 houseflies. Nice. Who's going to be in charge of that study? So, looking through there, I'm not going to take the time to put these in the calculator and put them in a list because it's going to be easy enough to do without that. But I do need my highest and lowest. Let's see. How is the longest a fly lived? 14? 14 seems to be the highest. The lowest number of days, 4. So I need a number line that goes from 4 to 14. So leave some vertical space. Our dots are going to go above. So I'm going to come down a little bit. making a number line that goes from 4 to 14. Okay. So now all I need to do is let a dot represent each housefly, and I put it above the appropriate number. So you can see the first two houseflies live 9. Then these two are at 4. So every dot represents a fly and how many days they lived. Just looking at the numbers. 9, 6, 7, 11, 13, 11, 6, 9, 8, 14, 10, 6, 10, 10, 8, 7, 14, 11, 7, 8, 6, 11, 13, 10, 14, 14, 8, 13, 14, 10. I hope I stayed on the right line. But you get the idea anyway. So these are the days, number of days lived. Housefly. Lifespan. Okay, the next type of graph I'm not going to do an example of because you've been doing them forever. It's just a scatter plot. For paired data. So when they give you XY ordered pairs, you know enough how to plot them. So I'm not going to waste time on that. I'll give you one in homework. Number 5 graph is called a time series chart. To me, the name's a little misleading. A time series chart is a scatter plot with time on the x-axis. So, let's take a look. I can squeeze it in here. Number 28. So it says use a time series chart to display the data. The data represent the ultraviolet index for Memphis, Tennessee at noon from June 27th through the 30th, 1998. So it's a 4-day time series, and then the UV index. I don't know what those numbers mean, but we'll make a little time series chart. So, scatter plot. Okay, the x-axis has our time values. Our times are the dates, June 27th, June 28th, June 29th, and June 30th. So we'll put a break. Start ending at 0. So June, what did I say? 27th. June 28th. June 29th. And June 30th. And then our UV index, we need 6 through 9. If you want to put a little break here and have it start at 5. not necessary. We only would have had to go up to 10 if you wanted. 5, 6, 7, 8, and 9. And then we'll just put a dot for each one. It's a scatter plot. So June 27th, we're at 7. June 28th, we're at 6. Then it jumped to 8. And then 9. And it is a scatter plot, nothing connected, no trend lines. That's it. Okay. Okay, we have 2 graphs left, and what makes these 2 graphs special is they're the only graphs we have for qualitative data. We haven't done anything with words, the data that we gather that are words, like names and such. So we have 2 graphs for qualitative data. There are 2 of them. They are the Pareto chart and the pie chart. Okay, a Pareto chart is a bar graph where the bars are increasing in height. So our example here is going to be, I'll give you a little table of information. Let's see, this was the transportation mode. Yeah. Oh, this is the one I'm doing right here. People that traveled by bus, by airplane, by subway, and by Amtrak, and this was the frequency. And let's see, the number of inner-city passengers in millions traveling by bus, air, subway, and Amtrak in 1995. So, nice little history lesson for you. So I'll write those numbers down so we have them. You've got bus, airplane, subway, and Amtrak. And then the frequency, and these are, they said were in millions. So 359, 499, 351, and 20. And I rounded all these off. We're going to go like that. So, we'll make, it's just a bar graph where each bar represents how many are traveling by each mode of transportation. So our y-axis, again, is going to be our frequency. So we've got to get up to 500. So, pick a good scale there. So like maybe 50s, 100, 200, 300, 400, 500. And now, to be a true Pareto, you want your bars in increasing height. So you want your smallest one, the Amtrak, maxing out at 20 here, and that's 50, so it's a very small. And again, it's just, you have to say what it is. This is not a number line because these are words. This is the mode of transportation. This is our Amtrak. And then our next one, 351. So, 351. 351. So I did not have to make the bars touch either. That is Subway. And then 359, just a smidge taller. There's our bus. And then our 499. For the airplane. Sometimes you'll see the graphs with the tables not there. Maybe they'll put the actual number here. Sometimes we'll leave them off completely. It all depends on the purpose of the graph, how much data how much information you really want to give out. Okay, and our last one, which does require a little bit of math. The first time we're going to do some math this semester, is the pie chart. Making a pie chart. Pie chart. Shows the relationship of the part to the whole. And all I really care about is that you can do the math to tell me how big each piece of pie is. Not that you can take out a protractor and compass and build it. But here we go. Let's go through the steps right through the example. I'll give you the steps. So let's start with example 6. Where did I get this data? I don't know. It looks like favorite colors. So color. So asking people what their favorite color is, and here are the results. Purple, black, white, gray, green. And here's our frequency. 350, 125, 75, 175, and 50. So given that information, I would like you to make a pie chart for it. So you have to make each pie piece represent the proportion that's picking each of these colors. So if you were here, I'd ask you what's your first step you think it is. Your first step is to total up how many people you had in your study. So first is to get the total. So if you add all of these up, 15, $775 apparently. 775. Okay. Now your second step is to find, well, what percent of my people pick purple? What percent pick black? What percent? Your percent is your second step, where you take each one and divide by the total. Don't bother with decimals, leave them as fractions. Keep everything, save all rounding till the end. So I'm just taking each number and dividing by the total, leaving it as a fraction. If I was to actually divide it out, put down a decimal.
Mason LaChance, if you are in the building, please come to the office. Mason, come to the office.
So almost 45% of my circle is going to represent purple. So now that I know the percent for each of these, if I'm going to build a pie chart, I'm going to have a protractor in my hand. I need a degree measure to make each piece of pie. So the very last thing we're going to do is figure out the degree the central angle. So if you think about it, a full circle is 360 degrees. I want 45% of 360 degrees. So the step I've got to do, my very last step, is to take each of these fractions and multiply by 360. So, and now I'm going to round to the nearest whole degree. So I'm going to save the rounding till the very end. So I'm going to make this one 163 degrees. So times each of these fractions, 125 divided by 775 times 360. And I get 58 degrees. And you just follow that all the way down. Timesing by 360, you will have 35 degrees here, 81 here, and 23 here. And if you actually took the time, you could make each piece. So 163 degrees, we know 180 is going to be straight down, maybe like that for purple. And then just keep adding on the rest of them. I'm not going to take the time to do that. But that ends our second section.